A physics lab just reported something that sounds completely impossible. Light came out before the atom was ready to release it. To understand why this is strange, you need to know what normally happens. When light hits an atom, the electron absorbs the energy and jumps to a higher state. Then it falls back down and releases a new photon. That process always takes a little time. A delay. Cause first, effect second. That is the rule. So what happens when that delay goes negative? When the measurement says the photon came out before the process was done? Is that even possible? Or did something break in our understanding of time itself? Here is what the experiment actually did. Researchers cooled a collection of atoms to near absolute zero. At that temperature, the atoms barely move at all. Then they fired photons through the cloud. Most passed through or interacted normally. But some showed a negative time delay. The measured arrival time of the output photon appeared to come before expected. Not by much, but the signal was clear enough to report. To understand why this can happen, imagine a choir of 10 people all humming slightly different notes. Each person starts and finishes at their own time. But together, their combined sound can peak earlier or later than any single voice. The combined wave shifts, not because anyone cheated, but because of how the individual waves overlap and add together. Quantum atoms work the same way. So what caused the negative delay? The photon did not actually travel backwards in time. What happened is that the quantum states of many atoms interfered with each other. This interference shifted the phase of the outgoing photon wave. And when scientists measured the delay using the wave's phase, it appeared negative, not because causality broke, but because phase and time delay are not the same thing at the quantum scale. Think of it this way. A clock measures time. But a wave has a phase, a shape, that can shift without information moving backwards. What shifted was the shape of the wave. Not the signal. Not causality. The wave looked like it arrived early. The physics did not break. But here is the part that should still make you uncomfortable. This experiment shows that at the quantum scale, the boundary between cause and effect is not always clean. Our definition of time delay, the way we measure it, may not perfectly match what is actually happening inside the quantum system. And that gap between measurement and reality is exactly where physics gets interesting. And by the way, this result has not passed peer review yet. It needs replication. So hold off on the time machine jokes. For now. Time did not go backwards. But our model of time just got a little more complicated. And that is the most honest thing physics can say right now. Follow for more science that actually respects your intelligence.